Hello everyone and welcome back to the next lecture of control systems. In this presentation we are going to have the review of Laplace transform part 4. And in this presentation we are going to continue our discussion on the properties of Laplace transform. So let's get started. Till now we have discussed 4 properties of Laplace transform, and the 5th property is the time differentiation property. We also call this property as the differentiation in time domain. As the name suggests, we will now differentiate the function in the time domain and will check for its Laplace transform. So, if f of t is having a Laplace transform f of s, then derivative of f of t, which is the differentiation of the function f of t, will have a Laplace transform s multiplied f of s minus f of 0 minus. In this case, f of s is the Laplace transform of f of t, and f of 0 minus is the value of the function f of t when t is equal to 0 minus. We call this value as the initial value or the initial condition of the function f of t. So we can say that whenever we differentiate the function in the time domain and check for its Laplace transform, then the Laplace transform of the original function will be multiplied with s, and the initial value of the original function will be subtracted. Similarly, if I differentiate this function one more time, then the second order derivative of f of t will have a Laplace transform s multiplied with s multiplied f of s minus f of 0 minus f prime of 0 minus. Now in this case, this particular factor s multiplied f of s minus f of 0 minus is the Laplace transform of the function derivative of f of t. Because now we are differentiating this function and checking for its Laplace transform, so the Laplace transform of this particular function will be multiplied with s, and its initial value will be subtracted. F prime of 0 minus here is the initial value of the function derivative of f of t. We can write derivative of f of t as f prime of t, and the initial value of f prime of t is f prime of 0 minus. Now if I multiply this s with this factor, we will get s square multiplied f of s minus s multiplied f of 0 minus f prime of 0 minus. And this is the Laplace transform of the second order derivative of f of t. So we can say that whenever we differentiate a function in the time domain, then by time differentiation property, its Laplace transform will be multiplied with s, and its initial value will be subtracted. So now we are done with the explanation of time differentiation property. Let us now understand this property in a better manner with the help of an example. And the example is given as, given the following differential equation, find the Laplace transform of y of t if all the initial conditions are 0. Note that all the initial conditions are 0. The differential equation is given as d square y of t over dt square plus 12 multiplied dy of t over dt plus 32 y of t is equal to 32 ut. Now in this case, when we apply the Laplace transform on both the sides to calculate the Laplace transform of yt, we will calculate the Laplace transform of these functions by using the time differentiation property. So moving on to the solution. If the Laplace transform of y of t is y of s, then the Laplace transform of second order derivative of y of t will be s square multiplied y of s minus s multiplied y of 0 minus y prime of 0 minus. Similarly, the Laplace transform of derivative of y of t will be s multiplied y of s minus y of 0 minus. And it is multiplied with 12, so by homogeneity principle, 12 will be multiplied in the Laplace transform also. The Laplace transform of 32 y of t will be 32 y of s. And in the right hand side, we have 32 u of t. The Laplace transform of ut is equal to 1 over s. So in the right hand side, we have 32 multiplied 1 over s. Now we are given in the question that all the initial conditions are 0. So in this step, all the initial value factors will become 0. And what are the initial value factors in this particular step? y of 0 minus, y prime of 0 minus, and this y of 0 minus. All these three factors will become 0, and we will have s square multiplied y of s plus 12 multiplied s multiplied y of s plus 32 multiplied y of s is equal to 32 multiplied 1 over s. Now in the left hand side we have y of s as common, so taking y of s as common we will get y of s multiplied s square plus 12s plus 32 is equal to 32 multiplied 1 over s. Transposing this factor to the right hand side, we will get y of s is equal to 32 over s multiplied s square plus 12s plus 32. Now we can factorize this quadratic equation, and we will have two factors, s plus 4 and s plus 8. So we can write y of s as equal to 32 over s multiplied s plus 4 multiplied s plus 8. And this is the Laplace transform of y of t, and we have calculated this by using the time differentiation property. And see, we have converted a complicated differential equation to a simple algebraic equation by using the Laplace transform properties. So this is one of the advantages of using the Laplace transform. These questions will be more clear to you when you will do some practice, and for that sake I will give you some homework problems. So now we are done with the time differentiation property, and in the next lecture we will discuss the convolution property. So these are the homework questions based on the time differentiation property. Pause this video and try these questions on your own, and when you get the answer, post them in the comment section. I'll end this lecture here. See you in the next one.